Hey, what's up everyone, and welcome back to another video. In this video, we are going to be walking through a bunch of real-world data science interview questions, and we're going to split this video up into two parts. In the first part, we're going to be doing coding interview questions using Python Pandas, and then in the second part, we will be doing non-coding questions that really make you think at a high level and are really judging how well you can approach new problems with kind of unique, novel solutions. I've spent a number of years interviewing and hiring candidates, so throughout the video I will be kind of sprinkling in some advice that I have from the interviewer's perspective on what types of things that we are looking for in a successful candidate. I think there's a lot of value in this video, so I am pumped to get into it. But before I do that, I want to give a quick shout out to this video's sponsor, and that is Brilliant.org. Brilliant is an online learning platform that offers courses on topics that range from math to physics to computer science. These courses are structured in an interactive manner, so instead of reading long articles and trying to digest all the information, you learn by doing. They have fun examples, relatable examples that make it a lot easier to understand sometimes very rigorous, very difficult concepts. In this video, some of our solutions to these coding questions will be pretty technical. And in order to really have a good understanding and a good intuition on how to approach them, it's very important to have a strong computer science foundation. A couple of the courses that I think are particularly useful for all of you on Brilliant are the courses offered on algorithms and data structures. These courses cover important topics such as arrays, trees, sorting, algorithmic notation, recursion, and much, much more. If you're interested in learning more and signing up, I have a link in the description, the top of the description of this video, brilliant.org/Keith Galli, where you can get signed up for free. Also, if you use that link and you want to sign up for an annual membership, it will give you 20% off to the first 200 people that use that link. Once again, that is brilliant.org/Keith Galli. All right, let's get into the video. All right, in this video, we're going to be doing problems on a site called Stratascratch. So it's free to use, but they do have some premium type questions that you have to pay for. But all the questions we'll do in this video are going to be free. And for your convenience, I'm going to leave links to every single question in the description. So to follow along, check that out. But basically on this site, you have a bunch of coding questions, a bunch of non-coding questions, and a lot of really good stuff coming from FANG type companies. So very real world stuff. So in this video, we're going to start off with kind of a progression. We'll start with easy, then we'll go to medium, then we'll go to hard on the coding side of things. And we'll do something similar with the non-coding questions. So to figure out the free questions, you can go to free questions. You can, search by difficulty. So let's say we want to do easy to start, and we want to sort by Python. Let us do this Microsoft question called finding updated records. And in these types of questions, you'll see the actual question over here on the left, and then the area for you to write code will be over here on the right. And then you can check your solution, run your code over here. So we first ran our code, we'd see our output is down here. And let's go through and read the question. So we have a table with employees and their salaries. However, some of the records are old and contain outdated salary information. Find the current salary of each employee, assuming that salaries increase each year. Output their ID, first name, last name, department ID, and current salary. Order your list by employee ID in ascending order. Cool, that seems fairly straightforward. Let's see what type of objects we are working with. So we're working with first name, last name, employee ID, salary, and department ID. So what it sounds like to me is that for certain IDs, we'll have multiple rows in our data frame. So actually, we can see this already with the output. So what we're going to try to do is just filter by those employee IDs and only grab the max row. So feel free to try this problem using the editor over here on the right. You can pause the video and then resume when you're ready to hear my solution. The basic approach that I'm thinking to take is that we could just we could sort this entire data frame by salary, so it's highest to lowest, and then just take the first occurrence of the ID over here. And what we'll be left with is all of this information but only the maxes of every one. So if we sort it like highest to lowest, and then we only take, for each unique employee ID, we only take the first occurrence that we see going top to bottom, then we're going to drop out all of that kind of fluffy, old, outdated information. So that's how I'm going to approach it, but there's many ways that you could do this. All right, so employee salary .head. And one thing I just want to show you too with how this platform works, if I do check solution right now, it's not going to work, and we'll see kind of we'll actually see the solution, so that's maybe not the best, but you'll see what's wrong about your solution here. So when you actually solve it correctly, this will say solved over here. But let's resume. So I think the first thing we'll want to do is do a sort values on this. So I'm going to be saying some of these commands from memory, but if you ever forget commands, one thing that I always do is I do Google searches, I look up how to do something with pandas, I look at the official pandas documentation, and then another resource that you can use if you haven't seen it already is that I have a pandas Python overview that's definitely worth checking out. It will definitely give you the core knowledge you need for these types of problems. But we're going to sort values, and we want to sort the salary. My voice just cracked. And the other value that we pass in here is ascending. I think by default, ascending is equal to false, so I don't think that we need to actually pass in anything here. So I'm just going to call this sorted salaries. And then we can print out the head of sorted salaries. Alt enter to run code. Look at that. That seems like it's lowest to highest, I think. Yeah, it's lowest value to highest value here. So we actually want to make ascending equal to false. And this is just a command I use so frequently with pandas that I just remember the keyword, the argument ascending. Look at that, nice. Julie Sanchez, absolute beast with this high-end six-figure salary. I like that. Okay, so now how do we drop like instances after the first time we see it? I'm going to go ahead and use Google to my advantage here because I don't remember this command off the top of my head. Only take first occurrence Python Pandas. Okay, drop duplicates. And we do subset equal value. This should be what we want. And I believe it will work top to bottom. You can look at the manual for more information, but I'm going to try that. So sorted salaries, we're going to drop the duplicates because if once we see another occurrence of that ID, we drop it, like we should be good and get the answer that we want. So that's going to be ID. And let's take the head of that. I'll call this DF final. DF like result. So actually we'll call this, let's be descriptive with our variable names. Like if you're doing an interview, one of the big things that an interviewer will look at when you write code is your code easy to follow? Is it descriptive? Do you use meaningful variable names? So I don't want to slack off. Let's like complete this like we would a interview question. I don't want to take the head of that. And let's do a new line, current salaries, we'll call this, .head. And obviously that's not going to work because I defined this as current salary. Let's run that code. That looks good to me. I like that. Let's see what we want to output. Their ID, first name, last name, department ID, and current salary. Order your list by employee ID in ascending order. So the last step that we need to do is sort values by ID. The nature of it is to go low to high, so this should be fine right here. I'll call result. So if we then just output, so the way you kind of output something is it will display the last line. So if I just do result like this, it should show us all of this information. That looks good. And now let's see if we solved it properly. Let's go. Cool. So this was a fun little Microsoft question. Easy difficulty. It wasn't too bad, but obviously it really depends on experience level. This would be very tricky if I was just starting out with pandas, but I've seen this type of stuff before. But let's move on to another easy one. So I'm going to go back to questions. I'm going to look at what we have available to us. Airbnb, I like that. Meta, Facebook, Yelp. Let's see what we got here. All right, I'm going to do the last one that we see here. Number of bathrooms and bedrooms from Airbnb. All righty, what is the question here? Find the average number of bathrooms and bedrooms for each city's property values or types. Output the result along with the city name and property type. So when I hear average number of bathrooms and bedrooms for each city's property types, I feel like I hear multiple things. I hear for each city, so we're grouping by city. For each city's property types, we're grouping by not only city, but also property type. So that's just screaming Python Pandas group by functionality. And then we'll have to take the average once we group by those values. So this should be a pretty standard type problem. It is definitely like something that you would do all the time if you were in the real world evaluating, like a CSV. And there's a lot of information in this. Property type, city. And then bedrooms and bathrooms we want to take the average of. So pause the video, try to solve it on your own, and then resume it when you're ready to see my solution. All right, with all these problems, I'd like to just run the code and see what we're working with here. This looks like a fun data set to play around with. I kind of want to see the raw data because I feel like you could do all sorts of cool stuff like this. So let's look at this in a little bit of a wider screen. All right, some cool stuff. A lot of information here. One thing you can always do if you are overwhelmed by how many columns this has, you could always start filtering out columns by just passing a list of what you actually care about. So property type, city, bedrooms, bathrooms. These are the 4 fields that we need to care about. So I'm going to just filter immediately by that, ignore the other stuff just so that I'm not overwhelmed, and just save this in a frame called Airbnb key details. I think that's a descriptive enough name for this problem. Let's go ahead. You can toggle this too if you need more room. Have fun like this. Alrighty. I can also make my screen a little bit bigger. All right. And now, pretty much every step of the way, I feel like I like just sanity checking myself and printing the head. Cool. This is pretty straightforward. I'm very particular with how I do things. So bothers me that property type is before city. So I'm going to do city. Actually, what way? Output the result along with city name and the property type. I don't think the order will matter for the output, but I feel like it makes more sense to me to see the city first, then the property type. There's no right or wrong answer here, though. Alrighty. So now what we need to do is we need to group by the city, group by the property type. So we can do that as follows. We can pass in a list to the group by functionality. City is the first column. Property type is the second column. And let's just run that real quick. What the heck? And I think if we just do mean, that will do the average of everything and we'll get a much more meaningful result here. All right, look at that. That's averages. But this is not super helpful for us because we don't see the city, we don't see the property type there. So there's a helpful little command that when you do a group by, you're specifying the index that it is city and property type. So if we do reset index, it's going to replace the index back into that data frame. So we should see 4 columns back here. Look at that. Ooh, I'm a Boston native. It's where I've spent like 8 years of my life, so I like seeing Boston up top here. I wonder if this is real data here. I assume it is. This would definitely make sense for averages for Boston. Not much room. Bet you LA is similar. New York City is definitely, oh wow, what the heck? Oh, Villa, that sounds nice. It's good with these types of problems too. Like what I'm doing right now is I'm kind of sanity checking. Do things seem to make sense? And in this situation, they do. So I think we take the leap of faith and we check solution. Also, I might just save this as like results or like property averages. I think that's a good descriptive name. Property averages. Run code one more time and check solution. Look at that, let's go. That was a fun one. It was definitely different than the first type of problem. Cool, so those are 2 easy questions. Let's progress into some medium and difficult questions. They should be a lot of fun. Back to questions. I'm gonna switch the difficulty level to medium. We're still at free questions. All right, next let's do, how about this problem from Google called counting instances in text. We have over here, the task is to find the number of times the word bull and bear occur in the contents. We're counting the number of times the words occur, so words like bullish should not be included in our count. Output the word bull and bear along with the corresponding number of occurrences. Okay, this seems straightforward enough. This is a bit different than like a normal data frame type problem, but the way that I think of this is we very much can use a regex to match bull and bear like exactly and not have, you know, bullish, etc. So we'll look at regexes. So we'll combine regexes with pandas to kind of help us do these counts, and then we'll have to do a little bit of extra work at the end. This is definitely covered in the Python Pandas tutorial that I've done in the past, so definitely check that out if you are confused. And what are we given? We're just given a file name and the contents. So I'm gonna just run this real quick. So we need to figure out all these contents from the file name. So how can we do that? Well, what we're really gonna need to do is basically do 2 filters and then count, I suppose. So we could just filter the rows based on the words. So I'm gonna call this bear words, and I'm gonna call this next one bull words. And bear words will be the file store, and we want to have, and I might honestly make this GFS equals Google File Store first, just so we have an easier name to work with, so it's a little easier when we're processing this. So bull words and bear words, and feel free to pause the video if you don't want to see my solution right away. Okay, so it's going to be GFS. And then we want to filter when GFS contents, I cannot type, .string .contains the word bull. So we might just think you could just do bull like this, but the issue is, as they mentioned, like bullish would be counted here. So what we actually want to do, and is this all lowercase? It's not all lowercase. So like another pre-processing step we could do is like lowercase everything, but we also can use the string contains. There's a built-in flag you can pass to ignore case, so I'll probably just use that instead. So contents that contains bull. What we want to do is we can do this in regexes. So you have to know about regexes. I can pass in a cheat sheet maybe. Let me see if I can find a cheat sheet. So I'll put this cheat sheet in the description, but the key thing we want to use here is what's called the \b, the word boundary. So that will capture spaces, it will capture the start of a line, etc. So it helps us kind of pick out exactly bool, but not like bool followed by boolish. So we could do, it might help too if we call this, you can do raw text with /b, bool/bool. So bool like that, and we should be able to pass in the flag. So I'll just share the documentation real quick. Contains pandas. So the last thing that we'll want to pass is we can pass in this flags. One of the flags we can pass through is e.g. regex.ignore case. So I'm going to import the regex library real quick, and we will pass in the flag re.I. So that's just the shorthand for ignore case. And we can copy this same exact code to capture the bare words. There might be a way to do this in a single line, but I think it's just easier to split into 2 lines. You could maybe make a function out of this if it made sense to you and just pass in the word bool and bare into the function. But I think that that will basically work. What we want to do though is let's like print out some things. Let's print out length of GFS, print out length of bool words, and print out length of bare words. 3, 0, 0. That's weird. I guess there's only 3 rows. Surprised. Oh, I guess we're counting. We're not only just taking the text, we're actually counting it. So we don't, it's not a 1, 0 type situation. It's weird that this doesn't pass though. Wonder if this would make it pass. Yeah, so all 3 of them have bool in it. You had to pass this raw text because it was trying to interpret this \b as something else. But okay, so this solution right here is what would have worked if we were just saying, does it contain the word bool or does it contain the word bare in the actual text? But because we need to actually count the occurrences, we need to do this slightly differently. I'm going to comment these out real quick. So we can do GFS bool count. It's going to be equal to GFS contents. That should give us the string, and then I think we can do dot count. Let's think. We have a string here with this. What function can we apply to a string to get the number of words? So the tricky thing here is we don't want to just count, we want to do count regex matches Python. All right, let's apply a function basically using the regex to this to get the count. So I'm going to do apply lambda x. So x is going to be the string value in contents. So we could call this something more descriptive. We could call it like text or something like that. So lambda text, well, the result of it is going to be re.findAll in the text object, or find all that same pattern we are looking for. In the text object. I believe that's the syntax. And then we would want to do just the, so we could then take the length of the result here. Okay, so we have this. I think that's applied correctly. We could then just see GFS real quick and see what we get there for that column. 1, that looks good. 1, looks good. 1, is there any more bulls? For this one, it's kind of annoying because we can just literally count. But I think that looks good. And let's do the same thing. Copy this line and do it for bear count. And then finally, what we need to do for the solution is it wants us to output the word bull and bear along with the corresponding number of occurrences. So I'm not quite sure how they want this to be looking, but I'm going to just call this bear, call this bull, and then just print out bull, comma, bear, run code. Oh, I guess then we need to do the count. So and then if we reset index, I think that will do the trick. Look at that. That looks good. Hopefully they like this. Yay. I'm curious what their expected output was. I guess it just looks exactly like that. So it took us a little while to get to that solution because we didn't do it properly the first time around. But we kind of could use that knowledge to help us get all the way there. I am very curious in this type of situation, the way that like the other solutions from users are structured. So I'm going to just look at that real quick. Oh, interesting. This is unique. What the heck? It is cool with this side that you can see this type of stuff. I don't like this .string.count bear and bull because I think that bearish and bullish would find their way into those. I don't know if that's the best. Like, there's different ways to solve these. You can look through all the solutions. The one thing, if you're doing this in an interview type setting, what I would definitely recommend is like write a test case where you have a data frame that has the word bullish in it. Does it trigger, this? Do these lines of code count the occurrences properly? Because we only had 3 rows in our actual answer, we couldn't really see, I don't think. But that's what you want to sanity check when you do this out in the wild. All right, let's go ahead and do another medium difficulty question. I'm going to kind of scroll through these. Let's go ahead and do this customer revenue in March question from Meta/Facebook. Question is here, calculate the total revenue from each customer in March 2019. Only include customers who were active in March 2019. Output the revenue along with customer ID and sort the results based on the revenue in descending order. Feel free to pause the video and resume when you want to see my solution. So pretty simple stuff here. See that we have a order date type, datetime 64 numpy type object. We're definitely going to capitalize on that. That all looks good. Looks pretty straightforward. So it's really just to solve this, it's going to be a filter by March 2019 and then a summation grouping by the customer ID and then summing. Okay, so filter, group by, sum. I might even just write that down. And like this is good in an interview, like kind of just saying this is what you plan on doing. So filter, March 2019, group by customer ID, and then some results. That's what we want to do. So let's start with looking at, I guess, what it looks like. order date's kind of like hard to process, but we'll make this much easier by augmenting the columns a bit. So we can go ahead and do order date. Let's just look at the dates specifically and then try to access using the Datetime component of Pandas, like maybe let's say just the year. Look at that. So super, super helpful is knowing that when you're working with Datetime types, as we see we have here, that you can do like .dt to access all sorts of specific date properties. And then you can do like .year, .month, a lot of very useful stuff. So to make our lives easier, how about we do orders year equals orders, what was that field called again? Order date. And we could even go as far as saying this is order year if we want to be very descriptive, and that's going to be .date, .year. We can then do orders, order month equals, and it should actually just be a single equal sign, orders, order date, .month. And now we can go ahead and filter. So we're going to want to say that March orders, March orders equals orders, and then we're filtering now, orders, order year equals 2019, and then and orders order month equals March. And I don't know exactly how, we should maybe just print out the orders order month real quick just to see what it looks like to make sure that we're structuring this correctly. So we actually want to do equals 3. Good syntax here would be to call March, set it as a variable, and just call it 3, just so we don't have a floating magic number. So we can delete this line here. We can uncomment this. So equals March. That should be good. All right, so we have March orders. We've done this component. Now we need to group by the customer ID. And we could sanity check here. Oh, did I not close this? I think I need to surround these in parentheses. It's kind of a weird niche thing about when you have multiple conditions within a filter in Pandas. Let's try running that again. March orders. That looks good to me. And we need to now group by the customer ID. And then we want to just sum the value. And we want to then finally then reset. Okay, I'll just run that real quick so you can see what that gives us. We see these total order costs. That's what we're caring about. But what we want to do is we still want to see the customer ID. So reset index will put the customer ID column back into our table. And then what we need at the end here, so we can call this like final result, is just taking the total order cost from that. And I suppose taking the customer ID and the total order cost. And if we, did I do something weird up here? And then finally, we can print out the final result. Oh, actually we need the last step was actually to sort values as well. going to sort March totals, we'll call this. March totals dot sort values, total order cost, ascending equals true, false, to make it in descending order. And we can save that as final result. And the ascending thing here, that should be familiar from one of those previous problems we did. Final result. That looks good to me. Final thing is to check solution. We got it. Nice. It wasn't too bad. Pretty straightforward. The key insight here was be familiar with datetime objects in pandas. And if you ever have a column that should be a date, but it's like not letting you access the .date or the .year, the command you're going to want to know is pd.toDatetime, I believe. Let me double check that. Yeah, this function is super useful if you ever need to convert a column into the datetime object so you can use the nice fancy things that datetime objects offer you in pandas. But cool, that was a good little problem. Let us keep going. So let's do now a difficult question. There's not many free hard questions, so we have small choosing, but I think we should find something good. All right, with these hard questions, why don't we just start at the top and do this one from Amazon called monthly percentage differences. We're going to be using dates again, so I think that's nice. At least we're kind of trying to use some of that same knowledge we've already used. Given a table of purchases by date, calculate the month-over-month percentage change in revenue. The output should include the year, month, date, and percentage change, rounded to the second decimal point and sorted from the beginning of the year to the end of the year. All right, so let's see what we have that we're working with here, because it isn't clear to me from this description what the output should look like exactly the format. So that would be one thing I would clarify if I was in an interview setting given this question. So we're going to have to take the months here, so we can grab the date and then the month object like we did in the last problem. Are we only in, one question to see is what are the unique years? Are we only worried about 2019, or will we see that we have other years as well? And I think this is a small enough data frame that we can see everything. Let's see. Yeah, it's only like 100-ish rows. And it's all 2019. You might have to write, because we have a smaller table for the sake of this interview question, we could just check that manually. But this is the type of thing that would be good to sanity check in code as well. Okay, so for this problem, again, I like taking a complex, tough question and breaking it up into smaller, easier things. It makes it a lot more manageable. So the things that I think about here is we need a group by the month. So we would first need to get the month as a column. So create month column, group by month, sum revenue, and then we would need to sort the month, sort months in ascending order just to get January, February, March, and then take difference in revenue. Now this is where it gets tricky. The easy solution would be just use a for loop or something, but how can we do it in a more Pythonic, more pandas way? That's what I'm going to kind of have to figure out on the go here. But at least we could start with the first items. Can I shorten this anyway? We'll see if we need to shorten it, but month equals SF transactions. We scroll down. Created at is what we care about here. So created at dot date dot month. So create month column. Now we need a group by the month. SF transactions dot group by the month. Sum the values. Reset the index. And this is kind of just coming from memory from the last problem. I'm just following the same steps. You see these steps over and over. They become a lot more natural. And then we would want to take the month and the value as our kind of results. Right? So that is this. We could then sort months in ascending order. And sometimes we need to reset this to something like month revenue, I would call this. And then, because sometimes you run a command, it doesn't, it runs the command, but you don't reset it and save it as a new variable, so you run into issues. Sorted monthly. Actually, let's just see if monthly revenue by itself is already sorted. Oh, look at that, it's already sorted, so we don't actually need to worry about that. But now, how do we take the difference? Well, one thing that is nice is there's a command in Pandas just called diff, like this. So I'm going to just create a new column called difference, or like value difference. How about that's kind of descriptive. That's going to be equal to monthly revenue dot diff. I believe that's the command. It's going to take the first row and then find the diff between that and the second row. I forget if, I think we'll probably have to specify that this is for the value column. Otherwise it would try to do it on the month column too, and that would just get all funky and stuff. Let's then see what monthly revenue looks like. Okay, this is like super useful here. I think, so we have this month's revenue minus last month's revenue divided by last month's revenue times 100. And so this could also be done with like a shift of something, like where you basically just shift all the values down by 1. I'm trying to think what's more useful. We're already doing this in our value difference calculation. So then we just need to divide it by last month's revenue, which is just the reverse of that, and then times 100. So I might just real quick also do like last month revenue equals monthly revenue value minus monthly revenue value. Oh, sorry, value difference. This is another way to get it. There are ways that you could just, instead of doing this diff command, get the like a shifted, so you have all the values in the column. So you have like, January, you have this value, February, you have this value. What you could do is just like take that column of values and then basically take that same, duplicate that column and then shift it down just a little bit. I just don't remember that functionality off the top of my head, and I feel like I'm going to get messed up when I try to use it. So I'm just going about it in a different way. Both ways are valid. And I would just kind of explain this in an interview setting, why I'm doing what I'm doing. I think this is very straightforward how it's working, which is nice. Like when your code is readable, easy to follow. Let's see what this looks like. All right, see, we get the values previously. So that looks good. So now finally we want to get percent change that is equal to monthly revenue value difference divided by monthly revenue last month revenue, just so you can see this neatly on one line. Right, that's good. Times 100. I think that's exactly the command. Yeah, that seems right. And then let's see, what does monthly revenue look like? Oh, and then we need to round it to the second decimal point. I forget how to do that off the top of my head. So it looks like the last step really is to get it in this format, our year column, and then round these percent changes to 2 columns. So how do we want to do that? I'm going to just do date formatted equals. There's this nice function called string format time that you can call on a date object. So I'm going to use that. Dot string format time, something like that. There's certain like syntax that you use with that too, so I'll just pull that in. String, like, and as you can see, like, I remember the gist of things that I need to do, but I don't remember everything. And how interviews usually work is like they might give you this as a screening question where you can kind of use your resources as needed to solve it. They alternatively might give you this as a whiteboard type question, in which case they wouldn't really expect you to know the syntax exactly. They'd be more so just making sure you're thinking in the right manner. I want pandas string format time. Year with century as a decimal number. That looks good. So it's going to be %y %d. This is very useful to know because I feel like in so many situations you want dates formatted in a specific way, you want specific stuff. So knowing this function is definitely helpful. So what we need to do is %y dash month. Oh, sorry, it wants month. So I think that's just dash m. I shouldn't have closed that so quickly. I was thinking day. Oh, it's %m. So it's similar to %a. %d, lowercase d. So finally, we want that creates that column. So final output will be date formatted and then the percentage change column. Oh, and we still need to change percentage change to 2 decimals. Round decimals, Python round to 2 decimal places, Python Pandas. That's another string format type thing. It's slightly different though. Round. Oh, look at that. There's a round function. That's nice. This is the number of decimals. Perfect. Easy enough. So I'm going to just say monthly revenue percentage change equals whatever the percentage change was dot round to 2. Series object has no... That's weird. Am I doing something wrong here? So I'm just grabbing the right column here. There's just some, what I needed to add was the .date, and then I needed to make sure we included date formatted instead of month, because that was really the important thing once we actually grouped by month. Date formatted, not an index. Here we're going to use some handy dandy printing. I'm not sure why I'm getting this error. This is weird. What happens if I just reset this to created at? Why is it not an index? I'm going to try just specifically doing what happens when we do this? That looks right. Where's the issue happening here? I'm going to just call this result, or dates formatted equals this. I don't know if something weird was happening. Very weird, very weird. Why is date not an index? Oh, because you can't sum the date. That's the issue here. I mean, we could just group by the date column now and then get date and value. Now created that's not an index. What the heck? Okay, that was an error down here. All right, that was frustrating. I don't know what happened there. That was funky stuff. One thing that's a little bit tricky about this platform is that you don't get super detailed like line error messages, but I think we worked it out. This all looks good to me. Okay, and this sounds right here. All right, come on, baby. Let's see if this is right. So what did we learn here? I mean, the trickiest thing is that when we ran the sum function here, you can't sum a date like value, like it just didn't work. So like we couldn't access that field when we tried to access it right here when it wasn't the field we were grouping by. I was just trying to I knew that month was working, so I tried to like ignore that, but we ultimately ran into an error there. Okay, we got the solution working properly. It wasn't too bad, but it was frustrating that we ran into some of those issues, but that's the real world. That's what happens. You do more of these problems, you get better, and hopefully you don't run into those errors in a high pressure interview setting. Let's do one more hard question before we move on to some non-coding questions. So let's do this one, premium versus freemium from Microsoft. Find the total number of downloads for paying and non-paying users by date. Include only records where non-paying customers have more downloads than paying customers. The output should be sorted by earliest date first and contain 3 columns: date, non-paying downloads, and paying downloads. So we have a lot going on here. We have some filtering. We have some definitely merging of like data frames and whatnot. We have 3 data frames here. You're gonna have to make sure that for a certain date you've merged together both the paying count and the non-paying count. So we'll probably have some group by and summing because we'll want to group by and sum all the values based on the number of individual users that were either non-premium or premium that day that did downloads. I wonder if there's, so you could have multiple downloads per user. So a lot of information here. I think one of the first things I see, I think there's multiple ways to go about this, but we have 3 different data frames, and in order to get the date, whether they're paying and what their user ID is, to get their the date and whether they're paying and the downloads, we need to link them by this user dimension. So I think this sounds like 3 joins or 3 merges. So we could get kind of a data frame all by doing that. So what I'm going to do is if we run this code, we see we just have 2 columns. What I'm going to do is I'm going to just call it data frame all equals ms user dimension dot merge. Well, we need to use the ms account dimension, and we want to put it on account ID. Let's see what df all gives us here. That looks good too. Just 3 columns now, and then we could also merge on ms download facts on the user ID. I'm trying to think if there's an easier way here. I think I'm just going to do this on a new line. So df user, I'll call this, and then df all equals df user dot merge with that bottom value, so ms download facts. And I like to do this first because it's just nice to have all the information in a single data frame. You're not bouncing around, and that's going to be on that. They both have the user ID, I believe. Yeah, so they both have user ID, so you can just do on equals user ID. That looks good. So some key things here: paying customer or non-paying customer or paying customer. We need to filter and group by those two parameters and then like merge those all together and get some values here. So what I'm thinking makes sense is basically we create new columns that's like paid downloads versus non-paid downloads, maybe for every single column here. And then we can filter just by having those two columns to kind of our final data frame that we're looking for, if that kind of makes sense. So I'm saying like, we want to know what type of downloads these are. So instead of just having downloads, we change downloads into like non-paying downloads and paying downloads, paid downloads for every single row. So obviously they're only going to have, it's always going to be some value or zero. So like if you had 6 paid downloads, you're going to obviously have 0 unpaid downloads. But I think that this should give us an intermediary data frame that's easier to work with. So that's why I'm thinking to do that. So I'm going to call this. So how about we do this? We're going to set everything to 0 here in the paid downloads and unpaid downloads, and then we can change them based on some filter conditions. So paid equals 0. And we could actually just do df like this, and that will initialize those two columns to 0 if I'm not mistaken. Let's just check. Okay, that didn't work, so we'll split them to 2 lines. So we see we have these 2 initialized to 0 columns here. And now what do we want to do? Well, basically we can take this and filter it. So we filter based on if it's paid or not. So paying customer equals no. Well, if that's the case, then we want to set the unpaid exactly equal to the downloads. I'm wondering if this will work. We'll see. Let's just sanity check. Do we have any values over here? Oh, that didn't seem to work. I'm just wondering if we filter this, if it will change the original object. Is it a mutable type here? Oh, we already have that. So we want to set for those spots, downloads or unpaid equal to df filtered downloads. We're still not getting any values here, so why is that? All right, so I'm actually going to do this in a slightly different way. Instead of setting these to 0, let's actually set them to the downloads column and then kind of go work the reverse way, work back. And so how we're going to do that is we're going to say dfall.loc, and if dfall paying customer is equal to no, well then we want to set the column paid equal to 0. And on the flip side of that, and I think we'll have to set this back to dfall. Set this back to dfall. If it is equal to yes, well then we want unpaid to be 0. So that should kind of fix the issue we were running into. Now let's look at dfall.head. Line 11 issue. Oh, I have like trying to do too much and I'm making simple mistakes. Oh. Man, oh man, I'm making very silly mistakes. With the loc function, we need to use syntax like this. Okay, that looks good. Where yes, we see paid is proper and it's set the right way. So that is looking good to me. So there's definitely ways to do it the other way I was approaching it, where we set things to 0 and then we filled in the gaps, but it just ends up being easier to like fill in the gaps with a constant number 0 when we filter on a condition than trying to like filter and then fill in those specific values from your full data frame. Definitely can do, but it's a little harder to walk through, a little harder to explain. So I approached it this way instead. And now what we want to do is we want to group by. So we could do a date format, I might call this. It's equal to this was we used this in our last example, but I might just do %y, %m, %day, in case the timing has any impact on this. Actually, it shouldn't, because they're all zeros, it looks like. Let's look. Yeah, it's always a 0 time frame. So it's not actually important when we do that. And it might screw up the final output value in comparisons. All right. dfall.group by the date. Then we want to sum the values. We'll reset the index. And then we really just need to take date, paid, and unpaid. Daily values, I'll call this. Let's look at what daily values looks like. That looks good. And then the other condition was the output should be sorted by earliest date first, which I think it is naturally, which is nice. But we only want to include records where non-paying customers have more downloads than paying customers. So to do that, we could do like final result equals daily values, filter daily values by only the condition where paid is less than unpaid. Final result. That looks good to me. Let's check the solution. Let's go. Nice work. All right, cool. I think that's all of the coding questions we're going to do. So let's kind of go back. We can go to some non-coding questions now. And we'll finish off the video with a few of these. In interview type settings, you're going to see all sorts of different questions for data analyst, data science type roles. You might see some probability questions. You might see some statistics questions. You might get some kind of high-level thinking questions. So we'll do a variety of different types of questions. So check the description of this video. I'll leave some links there. As a first question, we can do this problem called credit card activity. And it just says, how can you identify where a person lives based solely on their credit card activity? And so I'm going to pause right here. Try to think about the solution to this on your own. This is an easy level problem from Visa. And then when you're ready to hear my answer, resume. Okay, so this is a pretty straightforward question, I would say, but you want to make sure in an interview type setting that you're not jumping to conclusions. So there's a couple clarifying questions you'd probably want to ask before you just gave a solution to this type of question. I mean, at a high level, if someone lives in a certain area, you're going to see on their credit card statement purchases that are around that area, right? So you probably could basically take a circle around where they actually live, and all of their purchases will kind of be in there. So you take maybe like the averages of their latitude and longitude, and like that's kind of your position that they probably live. So clarifying questions you would want to ask in an interview type setting is how like precise should we try to be? And that's going to really vary person to person. But the other question that is really important is what type of time window do we have? Like, how much credit card activity do we have for this person? Because a person might be on vacation. They might be on vacation for a month, and they're going to be making purchases, all around their vacation location. And so is that where they live? Like, I guess it is for vacation, but it's not their home. So we need a big enough window where maybe they go on multiple vacations, but they kind of always come back to that same home base. So I think that's like kind of the crucial clarifying thing here is like, okay, how much window do we have? And then let's say if you have 12 months, well, if they spend 6 months and you see all points around a certain location 6 months of the time, it's safe to assume that that's where they live. And you can kind of do some averaging of latitudes and longitudes. I mean, you're not going to have that precisely from their credit card activity, but you could reverse search, business locations that they shop at and kind of pinpoint on a map those locations and then try to get some precise value. So that's how I would approach it. And why I say don't jump to conclusions is because, they might be traveling. So that's an important thing that I would want someone to think about before they just shot into an answer in an interview. Next, let's do a IBM question, easy. This is going to be a statistics question. Okay, what methods would you use to detect outliers in the data set? At a high level, this is a fundamental component of what we do as data analysts, data scientists. So this is crucial that you have a sense of this and can kind of speak on behalf of this for different types of data. At a very high level, the way that I would approach this in an interview is first off say, the first step that I do when I am working with an unfamiliar data set is plot it out. So this might be a matter of plotting coordinates in an XY plane. It might be grouping up coordinates and binning them and doing some sort of bar chart or box plot to get a feel of the data. And then, from that, you can kind of visually already see some outliers. If you have points that are lining up in a linear format, and you calculate like a linear regression on those points, and it's, a pretty tightly fit line, but then you have one point that's like way up, in no man's land, then that definitely is an outlier, and you can kind of see that visually. So visually is like the first approach that I would take. But then you also want to get more mathematical with your answer. And, the interviewer is probably gonna like follow up on different components. But another thing that I might talk about is, oftentimes in data sets we see normal distributions. So we see a distribution that kind of looks like this. My arms are the tails. And, we have the bulk of our mass in that central area. Most of the points fall in that space. So mathematically, what an outlier in this case would be is you calculate the mean of that, and then you calculate the standard deviation. And points that, let's say, fall 2 standard deviations away from the mean, those would be outliers. You could even go as far as talking about like z distributions and like z tables. This is kind of a more concrete way to look at normal distributions. So to kind of see what I mean about that, like I'll just kind of share this chart. Like 2 standard deviations off the mean is, only 2% of the graph. Like you can kind of be mathematical talking about normal distributions and the like. So that's kind of how I'd approach that question. This is the type of question where, they might follow up with you in a specific manner and might ask specific things like, okay, we're talking about linear regression now. How would you calculate an outlier? And same type of thing, let's say we calculate a line. You can calculate how far away it is from that projected line using mathematical formulas. And kind of that's how I'd approach this at a high level. Moving onward, let's do a probability question. Okay, so this question is called probability of having a sister, and it's a medium difficulty question from Google. And so we're given the following. Assume the distribution of children per family as is given in the table below. So the number of children, so like this means right here is that there's a 30% chance of having 0 children in a family. There's 25% chance of having 1 child in the family, and so on. So consider a random girl in the population of children. What is the probability that she has a sister? Okay, so there's one, I think, assumption you'd want to clarify with an interviewer right away is it a 50-50% chance that you have a male or you have a female, brother or sister? Because that's kind of an important clarifying component, because it doesn't say that they have a sibling. It says specifically sister. And this is distribution of children. So that's like a key thing to keep in mind. So how I would think of this is, first off, what's the probability that they have X number of siblings? First calculate that, or I guess let's say, what's the probability that they have X number of people, X number of children in the family? And then given they have X number of children in the family, what's the probability that one of those children is a sister? So this is like classic like Bayesian type stuff. So I'll kind of type this up as I go. So what we're looking for is probability of like sister. And so that's going to be equal to the probability that you have a sister given you have n children equals 0, which would be 0, so we wouldn't even need to consider that case, plus the probability that you have a sister given that number of children equals 1, plus, and so on. So I'll just fast forward as I type this in. Okay, so these are all of the probabilities that we want to consider here. And so let's start filling in and calculating these probabilities. And the reason that this works is because this captures the entire space of probability. It captures 0 children all the way up to 5 or greater. So let's use the table to help us out here, and also just kind of use logical thinking to fill in some of these values. Well, if there's 0 children in the family, then this is obviously going to be 0 because you couldn't have a sister in that case. So we could just eliminate this, or we could just say it's 0, but I'll just eliminate it for sake of simplicity. Probability of sister if the number of children is equal to 1. Well, if the number of children is equal to 1, and we're talking about a specific random girl in the population of children, well, she can't have any siblings because there's only 1 child in her family. So this is also equal to 0. So we're eliminating things as we go here. I'm going to jump a little bit farther forward and consider this case. We see here in our probability table that the probability of them being greater than or equal to 5 is 0 down here. So there's no chance that there is even greater than or equal to 5 children. So this is also 0 for a different reason. So now we're actually just left with 3 cases. So we just need to calculate these probabilities. All right, well, I'm going to write this on a new line. Oh no, I don't want to go there. Well, probability of sister if the number of children is equal to 2. First off, we have a probability of number of children equals 2. That equals 0.25. So that's going to be multiplied by whatever we have here because we need to kind of hit this remaining space. And then let's think about specifically, if there's 2 children, what is the probability that you have a sister? Well, that's just going to be the probability that the remaining 1 child is a girl. So that's just going to be 1/2 because we're assuming if the interviewer gives us the okay, the assumption is it's 50% chance boy, 50% chance girl. Plus, we're going to do probability number of children equals 3 times, well, if there's 3 children, then you have 2 siblings, you have 2 chances to have a sister. So the probability that at least one of those is a sister is going to be the inverse, I forget what you call it, the complement, not complement. Basically, it's going to be 1 minus the probability that both are boys. Because if both are not boys, then the leftover probability is what you get for probability at least one of those girls is or one of those children is a girl. So the probability that both is boys is going to be 1/2 times 1/2. So you kind of have to hit on both of those conditions. So it would be 1/4. So the overall probability that it's going to be a girl is going to be 1 minus 1/4 because that's the inverse, the kind of the complement of the 1/4. 1/4 being probability of 2 boys. So this is going to be 3/4. Then plus probability of number of children equals 4 times, well, if there's 4 children in the family, then you have 3 siblings. So 1/2 times 1/2 times 1/2 is the probability that all 3 of those siblings are boys. So that's 1/8. So it's going to be 1 minus 1/8, which is also 7/8. And now we can start filling in these values from our table. First value here of children 2 is equal to 0.2. So 0.2 times 1/2 plus 0.15 times 3/4 plus 0.1 times 7/8. And so it might help to make these all fractions. So this would be like 2/10. This would be you could say 3/20ths, right? Because 5 times 5, yeah, that works. And this would be 1/10. So this will just make our calculation easier. So that equals now 2/20ths plus 9/80ths plus 7/80ths. So what does that give us? Well, the first one is equal to 8/80ths because we multiplied by 4 plus 9/80ths plus 7/80ths. And that finally is equal to 16, 24, 24/80ths. So if we reduce that down, 8 goes into 24 3 times, so that's 3/10ths. So we get 3/10ths, which is equal to 0.3, which is equal to 30% chance, or 0.3. So that would be my posted solution. And let's see the solutions from users. Look at that, 30%, 0.3, 30%. We did it, nice. I love probability, it's fun. If you need a good book to learn probability, I really liked the textbook that I used in university. So that is this book right here. I'll link to it in the description. I'll share like the Amazon link. But I thought it covers the core principles of probability well, but it's not too massive of a book, and it has nice visuals and everything. Great book. I love probability. Nice work on that problem. All right, let's do another problem. This one's called Uber Black Rides. So if you're not familiar with Uber, ride sharing service, if you're not familiar specifically with Uber Black, well, those are kind of the luxury cars that you can call and you know, get to your destination in fashion. So if you're trying to ball out on a hot date, you know, Uber Black might be the way to go. I never ball out like that, but that's just me. But the question here says, Uber Black rides have dropped 10%. How would you investigate this reduction? So a question like this is so important in the data analyst, data science world, because it's not straightforward how you solve this problem. There's many different paths. So in an interview type setting, what the interviewer is looking for is, what ways do you think about a problem? Can you ask the right questions to kind of dive in and do useful, meaningful work to discover something about the business? So this is like a very real world. So very important to understand and do a lot of these problems. If you have someone that you can do these types of interview questions with, definitely do some like mock interviews where you kind of go back and forth. But how would I think about this problem? And feel free to pause and try it on your own before I go into it. All right, so there's many different things that I'd be thinking about here. You know, you want to consider, you know, is it specifically Uber Black that's down? If all Uber rides are down, then, you know, and they're all down, let's say 10%, then, you know, it makes sense that Uber Black would also be down, you know, a similar metric if there's just not as many drivers out. I think then the other side of things is I'm going to just say specifically Uber Black that's down versus all of Uber. I also would consider, like, so this is very important, just like kind of drilling down on that. Like, is it relative or is it, you know, a universal thing that rides are down? Other questions I would investigate is like, you know, what year are we talking about? If we're talking about these past 2 years or past 3 years with like the pandemic, you know, maybe it's down because it's down because businesses are closed. So there's not as much of a need to take those Uber Blacks. Specifically, like pandemic would be an interesting focus because, maybe you still need to get places, but maybe they're not fancy bars, fancy restaurants where you need to drive in style. So, the pandemic may have an influence on this. Other things to consider here. Did anything change about Uber Black? So any specific changes to Uber Black? And so when I say this, I'm thinking about things like, did they increase or decrease the vehicles that qualify? If they started being more strict, if business said, okay, this certain year can no longer, like instead of having cars that are within 10 years of being produced, now we need to only have cars that have been made in the last 5 years. Something like that. Like if there's a increased strictness, then you might naturally have less cars on the road. Other things to consider is like price. Price increases or decreases recently. On the price increase side of things, if they become too expensive, then people aren't going to book them. On the other side of things, these are nice cars that the drivers are driving. If they're not making that much to use Uber Black, then it might not be worth them to even get on the road. They might be working for Lyft or another service, or maybe do private contracting. So think about these things as well. So I would kind of book all of this stuff that I just kind of mentioned under the umbrella of topics to investigate. And I would lay this out with the interviewer. Ask clarifying questions, ask what assumptions that you can make. Maybe ask questions like, hey, how much were total rides up or down during the same time period? So when I say year here, specifically, I might just put in parentheses time period. You kind of want to have that start and end. But ask these clarifying questions on, how other factors influenced. Because we don't have the data, because this is a non-coding question and you'd be kind of asked this in a person-to-person, face-to-face manner, you're not expected to have exact approaches, exact details, because we don't have the data. But the other thing you would want to mention in this type of interview question is possible testing/investigation approaches. How, if you did have data, how would you quantify these things? How would you see if your hypotheses were right or wrong? Well, there's a few things that I would look at. Can we do back testing on our data? So, looking back 10 years in history, what is the general trend of Uber Black rides? Maybe they're up in the winter months when it's cold, but they're down in the summer months when you can just walk to a destination. So I would look at our old data and see if I can learn anything from that would suggest, which of our hypotheses might be true or untrue. I would ask for data on, prices, price changes. I would ask for data on when any policies regarding, so data on prices, global increases/decreases, etc. I would ask for data on Uber Black qualifications. If you specifically have a timeline of events like, okay, we let these cars in, we let these cars in, we let these cars in, and then like at some point that was reduced, then that could be very much a key indicator. Plotting both those events along with the overall number of Uber Black rides could help you really see some sort of relationship and correlation between the two factors. What other ways that I would possibly test this? I definitely would be plotting the Uber Black rides compared to other types of rides and cumulative rides. This would help see if I could find any sort of trend where maybe Uber Blacks were down, but the total number of rides increased and the total number of regular Uber rides increased. Like, these are the types of things where you can start piecing together the story. You start piecing together these different components, and that will ultimately help you kind of start telling a story about the data. Also be chatting with business folks, business people in the team, because they might have information that you wouldn't just realize from the data alone. So definitely work closely with the business people as well. But overall, I think like these points that I kind of hit on, these are the types of things that an interviewer would like you to be discussing. So really, it's just, there's no right or wrong answer. It's how are you thinking about this? Are you considering different unique cases and situations? And then can you take those and run with it? They might ask you specific follow-up questions, so just kind of be prepared to back up what you're saying. Hopefully this all makes sense. All right, let's do at least one more question. Might do two. It's been a pretty long video though, so I don't want to get too crazy. All right, this next question is considered a hard problem, and it is from Capital One. So the question is, how would you approach the task of processing a terabyte of data using a Python script? Well, this is like right up at least my personal wheelhouse. So I have a lot of thoughts on this, but if you're not as familiar with Python, it might be a little bit harder. But I think just really try to hit on some key components. Once again, you're not actually writing code for this, so you can't, actually implement this, but I think it's a matter of, are you thinking about the problem in the correct manner? So how I would think about this, I don't want strike through, is there's a few different things to really process a lot of data in our script. And it's one thing to process that data, it's also another thing to process that in a time efficient manner. And it depends on what type of data that we're working with. If we're working with image data, it's going to be different than if we're working with a data frame, a CSV, maybe of a lot of rows of information. So clarifying questions to ask. What type of data is this? Whether it be like image, CSV, etc. That'd be a large CSV if it was a terabyte, but is it like a data frame type object? What is the goal that we're trying to accomplish with this data? If we need all of this data intact in the same format, then it's going to be different than if we're trying to like aggregate and reduce the overall size by processing means. I think that's kind of two good clarifying questions to ask. It's really hard to go much deeper than that unless you have some answers from your interviewer. But then, let's think about this. So approaches. If we are given an image, we're going to probably want to like downsample, downsize the images. That's like just a high level image topic, but I'm going to go even actually higher level than that to start. If we want to do this fast, we want to, maybe I'll add one more clarifying question. What type of machine are we working on / with? Machine / machines. If we can distribute this to many different computers, that's important to know. It's also important to clarify, is speed, like what is the most important factor? What are most critical factors? Like speed, size reduction, etc. Like if we don't care about speed as much, then we're going to take a different approach than, and also I might even say like simplicity of the code. And when I say size reduction, I mean like size reduction of the data set, simplicity of the code, because usually you have a trade-off here. If you want your code to be super, super optimized and fast, we would write more complex Python code to optimize that speed. But if we didn't care and we only had to run this once ever, that it could be fine if it took 12 hours if we had simple, nice code to use. So that's a trade-off to consider. These are good things to be thinking about, to be talking with your interviewer, and just show them that you're not jumping into this too quickly. That's like a recurring theme with any of these problems. Okay, so approaches. Well, given we don't know what these trade-offs are, I'm going to just list some kind of high-level things. We're going to probably have to stream the data. So we can't, I'm going to just say stream the data into memory. So specifically, if you want a specific example, in Python Pandas, if you were trying to process a terabyte of data, you would break it into smaller chunks. So you might break it up into chunks of like 200 megabytes, let's say, like 200,000 rows. Something that more easily fits into memory. That's how you're going to do it. And you can't be loading it all into memory at once. You're going to be taking that small amount, processing it, and then going. Next, another very crucial thing when you're trying to speed up code is and process a large amount is parallelizing. I can never spell this word. Making the most of your machine. If you have 16 cores, then you want to be running threads of processing on every one of those threads that you can. So if you have 16 cores or 8 cores to run, if you have 8 cores to run your code, you're going to be able to run 8 threads in parallel at one time. You want to make the most of that within your Python code. You also could then, if you have multiple machines you could distribute this on, you could split up that data and send a certain amount of the data to each one of the machines. So distribute among multiple machines. And this is all based on the assumptions that we are given by our interviewer. Let's say we only had one single laptop, then the streaming the data into memory in the Python Pandas of like small chunks along with parallelizing is the approach. But if we have 10 machines to work with, let's use all of them. Another thing to consider in a problem like this is, does the top piece of memory, so like if we're processing the first gigabyte of memory, does that have any sort of meaningful relationship with the bottom gigabyte of information? Like if these are massive, massive images, then you might need to process them kind of together. So another kind of thing to clarify. All right, other things to think about with this task. I think that we cover a lot of things here. You might be able to get into more specifics within like the parallel processing. I think spewing as much information as you can is always nice. Like One thing that will be important is like, do you need to lock certain variables? So if like one thread is processing a certain piece of memory that another thread depends on, do you have locks on your parallel codes? You don't want to run into what is known as, you don't want to run into race conditions, and these are other important things to consider. So think about this as well. If you're curious about this specific component, like how do you process large data files with Python Pandas, I actually did a video about this on my second channel. So I'll link that in the description, and I'll also pop it up either here or here. But I think that this covers a lot of the key aspects in a question like this. So hopefully you kind of have a sense of how you'd approach it from hearing me kind of ramble on about this type of thing. You might, because it said specifically Python script, I kind of stayed kind of vanilla Python, but you might also be able to talk about different libraries, frameworks, other tools that work in the Python ecosystem that are very helpful. You also might talk about like databases and where you're saving this data. Those are other things to consider. So a lot of clarifying questions in this type of task. But hopefully this kind of helps you understand kind of the key components. All right, I think that's all we're going to cover in this video. Hopefully you all found this helpful. If you did, be sure to throw this video a big thumbs up and also subscribe if you haven't already. If you want to see more videos like this, please let me know in the comments. You also can check out my second channel, Tech Trek by Keith Galli, where I've posted a few more examples. Once again, I want to say thank you to Brilliant for sponsoring this video. If you want to learn data structures, algorithms, and other computer science topics, be sure to check out the link at the top of the description, brilliant.org/Keith Galli. And sign up for free and potentially get 20% off. If you want to stay up to date on everything that I'm up to, be sure to check out my Instagram and Twitter at Keith Galli. I've been posting a lot of fun pictures on Instagram recently, so I'd love to have you all join along for that. All right, I think that's all I have. So until next time, peace.